Section 13.1, Sequences and Summation Notation, Part 1. Sequences. A function whose domain is the set of natural numbers. So these are the numbers that you can plug in to a sequence. 1, 2, not 2.5, 3, not 3.2. Notice that these are positive whole numbers. 1, 2, 3, 4, 5. That is the domain of a sequence. A sequence is an infinite list of numbers. Some of these lists can be described as a pattern or formula, and we'll look at practicing that a little bit later. Okay, so we're going to plug in 1, we're going to plug in 2, we're going to plug in 3. If I can describe the sequence as a formula, we can describe it as AN. Okay, the first term, A1, the second term, A2, third term, A3, nth term, AN. Find the first 4 terms and the 100th term of the sequence whose given. Let's look at these examples. Here's what a formula looks like. This formula is going to generate each term of our sequence. Some of our sequences alter in sign. When our sequences alter in sign, this is a common way when we start having to write the formulas ourselves. Altering in sign, we have -1 to the nth. Now, just to take a few minutes here, notice -1 to the nth. What is that going to look like? Okay, so when n is equal to 1, that would be the power of -1. We'd have -1. When n is equal to 2, that's going to be the power of -1. -1 squared is +1. When n is equal to 3, again, the power of -1, -1 to the third is going to be -1. N equals 4, -1 to the fourth is +1. And so what you can see is if our sequence alters in sign, then -1 to the nth is what we'll see in the formula. Or if we're trying to figure out the formula, that's what we're going to write as the formula. Okay, so let's go back to some examples. Find the first 4 terms and the 100th term of the sequence whose nth term is given. Okay, so first 4 terms, we're going to let... Okay, so first 4 terms, we're going to start out with n equaling 1, because remember that was the domain of the sequence. N equaling 1, n equaling 2, n equaling 3, n equaling 4, because we are asked to find the first 4 terms of the sequence, and the nth term. Oh, sorry, the 100th term. Okay, so n equal 1, we just plug 1 into our formula. 2 times 1 minus 1 is going to give us 2 minus 1, which is 1. N equal 2, we're just going to plug 2 into the formula. 4 minus 1 would give us 3. We'll plug in 3 into our formula. 2 times 3 minus 1, that's going to give us a 5. 2 times 4, which would give us 8. 8 minus 1 would be 7. This continues on an infinite number of times. When we're looking at the 100th term, 2 times 100 would be 200. 200 minus 1 would be 199. We could plug in 101, 102, 103. Again, this is going to continue on forever. Okay, so very similar example. For this next one, we're going to again find the first 4 terms of our sequence. Okay, so first term would be plugging in 1. So we've got 1 squared minus 1, which is going to give us a 0. We move on to n equals 2. 2 squared would be 4. 4 minus 1 would be 3. N equal 3. We have 3 squared minus 1. 3 squared is 9. 9 minus 1 would give us 8. If I can make a better 3 there. N equal 4. We're going to plug 4 into our a sub n formula, our formula that generates every term of the sequence. So that would give us 4 squared minus 1, which would be 16 minus 1, which would be 15. Okay, so we're going to continue on as many terms as they want to see. They want us to maybe focus in on the 100th term. So that would be 100 squared minus 1. 100 squared would be 10,000. 10,000 minus 1, 9, 9, 9, 9. And we can continue on, again, as many terms as they want to see. Okay, find the first 4 terms in the 100th term. So I think by now we kind of got a better understanding of what these are. If they want the first 4 terms, start out by plugging in 1. So that would be negative 1/3 to the first power, which would just be a negative 1/3. Move on to n equals 2. Negative 1/3 squared would be negative 1/3 times negative 1/3, and that's going to be 1/9. Then we have n equals 3, so that would be negative 1/3 times negative 1/3 times negative 1/3. That's going to be a negative 1/27. And then n equaling 4. Negative 1/3 multiplied 4 times is going to be a positive 1 over, let's see, if we take 3 to the 4th power, that would be 81. Okay, let's look at n equaling 100. And then sometimes, we might have a value that our calculator can't do. 3 to the 100th power becomes pretty large. So let's see what we can do to at least simplify the number maybe a little bit. Up top, if I take negative 1 to the 100th power, since the power is even, that's going to be a positive 1. So at least we can simplify that part. It's probably 3 to the 100th. That is too large for the calculator to handle. So we'll just leave it as 3 to the 100th power. Okay, so get rid of that. Pen. 1 over 3 to the 100th power. Now in this example, we wanted to pay attention to that altering in sign. Starts out negative, goes positive. Starts out negative, goes positive. Next one would be negative, goes positive. And so I can look at how that negative 1 to the nth power is what's generating alternating signs.